most exciting part of class. Okay. So the question before we got the quiz going was from section 2.4, number 5, I think it was. So I took this function and I graphed it, right? So I put it in here, just to take a step back out. So I got that. Is that right? Let's see. No, that's, oh shit, Jeff, you crazy person. All right, so what I'm gonna do right now is I'm gonna take that function. Yeah, go ahead, Jeff. Now, here's the trick. Basically what number 5 wants you to do is it says, okay, we're tired of making the graph for you. You go make the graph, right? And you guys can graph a function all freaking day long. It's just a question about how do I make this dumb line, right? You guys with me? So, are you supposed to know that's what number 5 is asking you to do? Sort of, because it's the same question as this. It just didn't give you. You have to find delta, correct? That's the point. And what's the point of this one? Find delta. Given this function, give this limit, blah, 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 right? Same question. They just didn't give us the graph, those bastards. So I have to make a graph myself. How far, so when we graph this, the limit should be 3. And how far away from that do I want to go? How far away from that do I want my red lines to be? 0.3 away. So I want to go down to, what's 0.3 down below 3? And I'm going to go up to, so if I graph this, it looks a lot more like what I'm used to. Now what really sucks about this graph is everything is happening right there. It's happening right there, right? So instead of doing that, I'd much rather bring this stuff towards me. You guys, somebody with me? Yes?
What about the x minus 2 greater than d?
That is, we're going to find that. So again, what we've just done is this is the function, and we've just drawn these red lines, yes? Mm-hmm. Then we have to determine what these are.
Right.
And what are these related to in this? What are these related to?
Delta 1.
Delta. Yes? Delta 1, Delta 2. I love it. You picked the smaller one. Kick ass. So, how do I find, on this problem, we did this problem. How do we find this x?
Plug in.
Well, here's the great thing. So on this problem, I had to plug stuff in. On this one, I can just let the calculator do it for me.
Yeah.
So here's something you might have forgotten. So number one of the coolest little things, and only a math teacher would say something's cool about this, but if I go to Zoom box, I can zoom in very specifically onto where things are happening. So that's going to be one corner of a box. So if I go somewhere and hit enter and I go down and over, it's going to make a box. So I want to make sure I capture all that whole, where everything's happening. Chapow. And you can make whatever sound effects you need. Yes?
Do you add the minus 3 onto the graph? Or like when you
Okay.
put it in?
What is this? You can't even see it, can you? But what do you know this is? 3, because I'm expecting my limit at 2 to be 3. And so isn't this 3 here?
Yeah.
It doesn't, I don't put it, it shows up. I don't put it. So if I put the function in and I go below 3 and above 3, I will automatically get this to show up. I can zoom in on it so I can make it look a little better. Doesn't this look exactly like a problem that could have been right here?
Yeah.
But we just made it for ourselves. So what's the next step? What do I need to determine? What's the one set of lines that are missing that I can see here, but I don't see here? What lines are missing? I've got a function, yes? I've got a function? Yes, I've got the red lines? Yes, what lines am I missing? The lines that go
Down.
boom. No, the lines that go down, yes. So I need to figure out what's the x value here. Do you see how I can see delta? I need you to see, so if I draw down, I can see delta. Delta's, and if I figure out the x value here, it's delta, yes? How do I figure out what that, oh,
It died.
no, he's taking a little nap. Sorry. How do I figure out what that x value is? It's where these two things intersect. Beautiful. So right above trace, do you see where it says calc? Everything on this top row is related to graphing. If I hit second trace, I can calculate stuff. And specifically, what do I want for this right now? The last two are calculus. The last two are math 180. If you didn't hear me, I said the last two are math 180. I don't know why. So if I go to intersect, it's going to ask me first curve. All right, one of the curves I want is the blue one. Is that cool? Then it's going to say second curve. Do you see how it bounced up to the red line for me? Enter, and then it's going to say guess. So I'm going to go right where it looks like they intersect. Okay, so what do I get?
1 point.
Yes, 1.51. So what would delta be then? What would delta be? Roughly like 0.49. You just do 2 minus this. Is that cool? Because it's how far away you are from the input you're trying to approach. What input am I trying to approach? 2. Isn't that the whole point of the problem? I'm trying to approach 2, yes? Okay. So this is one step away from being this problem, which we've done before, and I think everybody pretty much felt like it wasn't that bad. You just have to make your own graph, and you got this stupid expensive thing that'll make a graph for you. So what do you do to figure out? So that delta might be what? 0.49, right? Is delta definitely 0.49?
No.
I don't know yet, because I got to figure out this. Maybe it's closer. Remember that I always pick the delta that's smaller to make sure that I really am in there? Okay, yes.
To backtrack a slight bit, you would put it as 1.49 instead of 1.
No, definitely not. So what input am I approaching for this problem?
2.
2.
Right.
How far away from 2, because that's what delta is, how far away from 2 is that point? Is that x value?
0.5.
Well, roughly, 0.49 something, 0.487, right?
I see what you're saying.
So this problem is exactly the same as the problems that came before it. They just didn't give you the graph because they're like, you got a calculator. You make your graph. Maybe, yes? $24. Oh yeah, I did this problem. Okay. All right. What does C mean when you see C? Constant. Do you all agree with me? All right. Y equals 7. Is that a function?
Well, yes.
Totally, it's a function. All day long is a function because it passes the vertical line test, yes. It's one of the most simplest functions, just y equals 7. So c is a number, so y equals c is a function, yes? So what is the limit? All right, so if I have y equals 7, what's the value if x equals 3? What's the value of x equals pi? What's the value of x equals negative 18 trillion? Freaking 7, Jeff, because the output's always 7. So what is the output for the function we're looking at here? C. The output is always C. So what I'm trying to get you ready for is if you set up the problem, you're going to quickly determine something that we already went over. So on this problem here, don't I have to stay close to, get over there. Do I have to stay close to 1 so that I stay within here? because the sucker is got a slope to it, right? If I have a flat line, that's 7, because I keep saying 7. And I want to know, okay, what's the limit as x goes to a of 7? How close do I have to be? I need you guys to be with me. If I get a little bit far away from a, does the output change at all? No. I need you to see. So delta controls how far can it get away from the input so the outputs don't get too far away from the limit. But how far away can it get from the input and the output stays right on the frickin' limit? Forever. So there will be a weird little thing that happens. That's all I'm going to say for right now. You should get somewhere that something's infinity. Your delta can be infinity. If you get really, really far away from this, what's the output here? 7. What's the output here? 7. Aren't you right at 7? Are you very far away from 7? No. The whole idea is, how far away from the input can I get and have my output still close to what the output's supposed to be? That's the whole idea. That's delta, that's epsilon. If my outputs never frickin' change, I can wander as far as I want to. Because I'm always right on the frickin' output. So when you do the work, you should get something a little weird happen. Just to warn you. It's going to be some kind of infinity, yeah. Okay. Y'all like that one? Okay. Anything else from homework stuff? Has anyone gotten real quick answer to a question that you should be asking? Where should I be now? Where should I be now? The ultimate best place to be is to be starting to get into section 2.7. The you're on track place to be is to be in 2.6. If you haven't started 2.5, you are officially behind, right? Which again happens, you know, shit happens. I understand, but just so you're aware of it, you can still catch up, right? When is the test? Thursday. Okay. What do I think we're going to finish? We're not going to finish through 3.6. Just to let you know that right now. I'm not going to try to cram everything through 3.6 in. We're probably going to get up to 3.4. I told somebody that this morning, and that seemed to like make their entire week. So, just want to let everybody know we're probably going to get through 3.4 for this test. What's happening Wednesday? Holiday. So don't come. You won't be able to get on campus. So don't try. All right, guys. Anything else? Homework stuff? I'm sorry. 2 people had hands up. Yep. Question which one?
Question
30. Okay. Oh, okay, so 30. Yeah, so this is one of the ones I warned you about that I gave you that's a little bit weirder. Right? And I'm pretty sure if I remember correctly, they did an example. They did an example of a radical. And they did an example of a squared. Yeah. So use those to help. If the only issues you have in section 2.4 are number 30, and what's the other one? Oh, and the second, yeah. If the only question you're having trouble with is 30, and I think there's another one that's a little weird further down, but then you're doing great. Do what you can with number 30. Look at the example with x squared. I told you the minute you get above a linear, if you get a quadratic, it gets really, really crazy. So I just want to give you one of them to see if, just try it, right? You're all like, if I got time, buddy. I'm with you, I understand. And then you said what else?
Page 124,
Question 3? Okay, so 3. State the numbers. Oh, okay. Can anyone tell me how many discontinuities there are in this? Let me take this away. How many discontinuities are there? Yeah, how do you tell where there's a discontinuity?
The circle and then the
Yeah, the really kind of non-technical answer to that is, where do I have to pick the pen up to keep the graph going? So I'm cool. I don't have to pick my pen up. Oh shit. So there's a I don't have to pick my, oh shit, there's a discontinuity. So that's not good enough. If I ask you a question about explain continuity, if you say, well, it's what I have to pick up, that's not good enough for that. But just for discussing it, that's a really good, just eyeball. Where would you have to pick your pen up? And then it says, oh, is it continuous from the right? Is it continuous from the left? Yeah. So one definition I kind of skipped over is what does it take to be continuous from the right, continuous from the left? And I think they defined that, here we go. Yeah. So it kind of makes sense. I should have just asked you this. I was going to, and then I decided not to, but what was it again? It was number 3, okay. To be continuous at a point. Does anyone remember? To have a limit exist, what must be true?
Both points must be.
As you go from both sides, they have to agree, correct? To be continuous there, not only does it have to look as if the function is going there,
Has to go there.
the function actually has to go there, right? So not only does the limit have to exist, but whatever number that is, better be what the function is. So let me just get your gut reaction. At -2, is it continuous from the left or is it continuous from the right?
From the left.
Why is it continuous from the left?
It's a close dot.
Because it looks like it's going to this, and it gets there. This one looks like it's going here, but it does not get there. Cool. So continuity is all about, do you actually get to where it looks like you're going? All limits care about is, what does it look like I'm doing? And then continuity comes in and says, well, do you do it? Do you get there? Okay. Maybe. Okay. Okay. Is that okay? No? You don't like it? Like -4, is that continuous from the left or the right? Yeah, -4, is it continuous from either side?
No.
Why not?
Because it's not. they don't-
Because it doesn't get to anywhere at -4 now. So it has no chance to be continuous in any way if it's not defined at that point.
What about +4?
Yeah, what about +4? Is it continuous from the left or the right?
On the right.
Because does it get to where it looks like it's going?
Yes.
Yes. Now, where does it look like it's going from the left?
And negative infinity.
And what's the whole idea of infinity? Do you get there?
No.
So by definition, any infinite limit's going to be discontinuous because you never get there. You can't get there. If you thought you got there, take one more step. Oh shit! Right? You guys kind of maybe you lost me at welcome to 180. I'm sorry. Okay. So continuity limits are a little frustrating because they just never get to where they're going. No. It doesn't matter what's happening at that point because the limits don't even care about it. Continuity comes in and says, oh yeah, I care. Holy shit. So limits, you better exist, but then you better get there, right? Fill that hole in. Okay. What kind of discontinuity is this? Just to review.
Jump.
Removable, because you can remove that discontinuity by filling the hole in, yes? And this one would be a jump. This one would be infinite. I could argue infinite jump, but it's technically infinite discontinuity here. Yeah. I like it. So you could be continuous from one side, but when I just say, is it continuous at 4? No. Okay, I like it. Okay, maybe. All right, anything else? I know some other people had hands up, yeah.
I wanted to go over number 23 on 103. It wasn't any exact problem we had, but I noticed it was very similar to one of the quiz.
Oh, yeah. Okay. So again, before you do, now real quick, I didn't say this, but one of the 3 problems on your quiz, the limit problems, you should have just been able to plug the number in and get the answer. You didn't have to do a damn thing. So if you did the conjugate twice, you did it one too many times. One of your radical problems was not indeterminate, which means you could just plug the number in and get the answer. Done. So what do you always do first when I give you any limit question like this? Try to plug it in. Now what happens if I try to plug a 0 in?
You get a 0 on the bottom.
Don't just stop there, because that could be infinity, right? That's not indeterminate, but what happens on the top? If I put a 0 there, I get square 9 is 3 minus 3 is 0, so that's indeterminate. Now I do some stuff. And of course, you all know what to do this. What do I do to this?
Conjugate the top.
Yeah, multiply by the conjugate, yeah. I don't want to say conjugate the top, because then it sounds like we're in Spanish or something. Or French. Conjugate your verbs, yeah. What would you multiply the top and bottom by?
Square root of 9 plus h plus 3.
Square root of 9 plus h plus 3, is that cool? You guys with me? So if you didn't try that, try it. If you did try it and it went somewhere crazy, let me know. That one should come out kind of nice. What are you hoping happens after you do a little simplification? What must go away?
Terms must cancel.
The stupid h better go. It better die, right? Okay, I like it. Or cancel if you don't like my very violent mathematics. Huh? Does that make sense? No? So like here, do you see how the x minus 3, if it would just cancel, then maybe it could be something? So whatever I do, I want the x minus 3 to cancel. That's what tells me I'm on the right track with what I'm doing. If it doesn't cancel, it doesn't make any sense. Okay, maybe. Yeah.
So if you evaluate the limit and you evaluate the break, we just plug it in.
Yeah, what's the instruction say? Just.
Evaluate the limit and then exists.
Yep. So you evaluate it any way you can. So normally if I do that, I don't want to see any tables. We're trying to always move away from the tables, right? Tables got us started, now we're past it. Yeah. Although you had to do one today. All right, guys, anything else? Did I skip over somebody else? 27? This guy? Oh, okay. What do you do first? You plug in the number. And what happens when you try to plug a 0 in for t?
Get a 0 at the bottom.
0 on the bottom. More importantly, you also get 0 on the top. So real quick, if I get a 0 on the bottom, that could be some kind of infinity. So I better check the top also. Don't just start doing stuff if you get a 0 on the bottom. You gotta make sure you get 0 over 0. Is everybody with me? Okay. So you guys, you're shaking your head yes, but your eyes are saying no. Okay. So again, I only do algebraic stuff to a limit if it's indeterminate form, and this makes too much sense because the form it's in is indeterminate, so I gotta change it. If it's not indeterminate, I should be able to determine the answer. I shouldn't have to do anything. I should just be able to determine the answer. This crazy thing is indeterminate. Well, what do I multiply top and bottom by? Yeah, so square root of 1 plus d plus square root of 1 minus d, top and bottom. Never distribute. When you're using the conjugate for evaluating limits, don't distribute the t on the bottom, yeah? Because then you kind of lose the narrative there. You lose the story. You want what to happen to this t? You want it to die. You want to cancel. Yeah. Cancel culture. Be quiet. What would I do at number 28? Common denominator. Common denominator. So again, it's what are the main things you could do? There might be more than this, but you can use a conjugate, you can factor and cancel, or you can combine fractions. Those are the three big ones we've done examples of. Okay, I like it. Okay. All right, guys, we gotta get going. Here we go. So 2.5 continuity we did, 2.6 limits at infinity we did. The funny thing about 2.7 and 2.8 is I've already done most of the concept with you because it made sense just to kind of bring it up before. You're not going to believe this, but I have a handout. I have a stupid amount of handouts today, so oh well. So, first thing I want to do, let's do this. I really want to make something clear, and you're all like, that's a change. Be quiet. What is the main method we have at the moment to determine the slope at a point for something that's not a straight line? What method do we have to determine the slope of a non-straight line function? You guys all know this.
Y squared minus y over x.
Y2 minus 1 over x squared. Now, beef that up. Calculus that thing, right? Just to verb the word calculus as I die. Let's get going.
2 points.
What's up?
The fact that you need 2 points.
So it starts, yeah, sure. So it starts here. We are way past that shit, right? What's that look like in calculus now?
So F times A plus H.
F of
A plus H.
x plus h minus,
F
F
of
of
x
A.
over h.
and of course, we're gonna marry that with the idea of what that we developed. To make this perfect, I need to have 1 point. This has 2 points, unless I let h go to
0.
0. So what is the job? This is what the book called the difference quotient, because the book is silly. That's the actual name of it, but I still don't like it. What's this thing's job? If I do this, what do I find? Sure, rate of change, because that's another name for this slope. That's all this thing is, correct? That is the idea we've been developing. I just want to show you this, some nice notation that we use for it. So we use the notation prime. It's going to come back someday. There we go. This is read f prime of x. Calculus, roll it. That notation just means this. Now, just to give you a little peek at what we're about to do, chapter 2 uses the hell out of this. After chapter 2, we're only going to use this every now and again to prove some stuff, but we're going to move past this. Is anybody excited about that? Not yet. We're not yet ready to move past it. Okay. So let's do it a specific problem. Let's say I have the function, sure, let's make it exciting, x cubed. So I'll give you an example of why we want to move past this process. And I want to know the slope at x equal to 2. Come back. Thank you. So in symbols, how would I write this? What represents slope? What do I put on the F? Little prime dude. And I want the slope at what point? 2. So that's going to equal, the limit is h goes to 0, f of 2 plus h minus f of 2 all over h. Do you see how I just plugged stuff in? Is that cool? This we know. Now I specifically want to know the slope at 2, so I'm going to plug a 2. Let me stop for a minute. Yes?
Would you do that for, like, how would you know if you would need to use prime or just the original, like?
If I see a prime on my F, that means what comes after it is the slope.
Gotcha.
If it's not, so this is going to become huge very quickly in this class. You're going to want to be nice to yourself. You're going to know what the hell F is. You're going to want to know what the hell F prime. And guess what? There'll be an F double prime, because when I do this for X, I'm going to get a function. Correct? Doesn't that function have its own slope? Couldn't I just keep calculating the slope sometimes forever? Will we? No. Yeah, I had students from my fall 2009 class still calculating. No, stop. All right, I really want everybody with me. So we've done this before. We've done this before. All right, how do I do this? What do I need to construct?
X,
What-
2 plus H.
Yeah, I need to know what f of 2 plus h is, and I need to know what f of 2 is. So I'm going to construct those two things. I'll do f of 2. I'll do half of this. Oh boy, okay. You guys figure out this one. Bless you. Look how much work they did. They didn't have to work.
H plus.
Yeah, what is f of 2 plus h? What does it start off looking like? What's f of x? What's f of x? X cubed. So what's f of 2 plus h? 2 plus h cubed. You just replace x with the thing, yes? That's all. That's how function notation works.
A plus H cubed plus 4H.
No, you're trying to make it easier. Too bad. I don't blame you.
So A.
If I asked you, guys, real quick, you know what to do here. You know it. Your brain's trying to rebel. If I ask you to do 12 cubed by hand, what are you going to write down on your paper? 12 times 12, and then you're going to multiply what you get by 12, correct? So okay, how do you do 2 plus h cubed? 2 plus h, 2 plus h, 2 plus h. If I give you 3 numbers to calculate, none of you can multiply all 3 at once in your head. If I say what's 2 times 7 times 3, can anyone do all 3 at once? Nope. If you can, I want to take you and analyze the hell out of you. Our brains can't do this shit. So how do you do 2 times 7 times 3? I would do 7 times 3, and then multiply by 2, right? Good. So if I have 3 things to multiply, I do 2 of them, 1, and then I multiply by the last 2, yes? So if you write 2 plus h 3 times, the way that problem needs me to, alright, I can multiply these together, yes? Yeah, 4 plus
8H. 2AH plus
yeah.
4H.
So you guys doing okay? Jump on this shit now because it's gonna get weird. So if I just FOIL these things out, I get 4 plus 2h plus 2h, 4h plus h times h, h squared. That's like me doing 12 times 12 times 12. Okay, 12 times 12 is 144 times 12. Then I do that shit. Yes. That's exactly what we're doing here. Now, how do I multiply that stuff together? Just take turns. 4 gets a turn. 4 times 2, 4 times h. You guys with me? Keep going. Give everybody a turn. Everybody gets a turn. Now it's 4h's turn. Yeah, 8h, 4h squared. And now h squared gets a turn. H squared times 2 is 2h squared. H squared times h is h cubed. Oh no, oh no. Okay. Let me stop for a minute. You guys can all do that, right? I know part of you didn't want to. Just be very happy I didn't put a 5 there, yes? Will we have a 5 here? Yeah, we will. Are we going to develop a shortcut? Oh, hell yeah. I don't want to do a freaking 5th power. I might mention something about, yeah, well, in a minute. I'll show you something kind of cool. I'm going to use this later anyway, so I might as well show you now. So kind of reorganizing this, let me put this in descending order. Is that cool? So I get h cubed plus 6h squared plus 12h plus 8. You all could do that. I know you could. I know part of your brain didn't want to. But you gotta start to realize that is not much. That is very little work, so you can just eat that up. Little side note, don't even write this down necessarily. Well, maybe. We're gonna use this later. I wanna show you a different way to get this answer. Have any of you guys ever seen this? Jeff, if you do it right, you'll be better. There you go. You're like, I still haven't seen it, Jeff.
Yeah.
Do you guys see where I got the 2 from? 1 plus 1 is 2. So where did the 3 come from? 1 plus 2 is 3. 2 plus 1 is 3. You guys with me? So let me show you how this thing applies to what we're doing. So I could continue, couldn't I? I could continue this triangle forever. Who's the weird ass person that came up with this? Pascal. He has a computer program named after him that nobody uses anymore. I'm sorry, Pascal. But we still use his triangles. This is Pascal's triangle. And he let us use it. So watch this, watch this. Can you do x plus 1 squared semi-quickly for me? What is x plus 1 squared? What are the, yeah, x squared plus x plus x plus 1, so x, what are the coefficients?
1, 2,
1, 2, 1. So what do you think x plus 1 cubed would be?
x squared.
1x cubed,
Plus 3x squared plus 3x plus 1.
and that's exactly what it is. Isn't that silly? The Pascal's triangle is related to something called combinatorics, which you would hit if you did probability, and if you have it, you're fine. You don't even, we're gonna use Pascal's triangle to kind of prove a shortcut, and then you could forget about them if you wanted to. The Pascal's triangle is freaking awesome. But I understand I'm a math guy, I might be the only one that did. So watch this. If I have, what did we actually have? Didn't we actually have like h plus 2? Just to put it like that, yeah? So watch how this works. 1, 3, 3, 1, yes? I would have 1 h cubed, no 2's, yes? Plus 3, this power goes by 1. How many 2's did I have here? None, so now I'm gonna have 1. Plus 3, 1 less h, 1 more 2. Plus 1, no h's, all 2's. Is this what we got? H cubed plus 6h squared plus, what is that? You can do it to 12h plus 8. Is that what we just got? Is that what we got? Yay, good, because that's right. All right, good. Is that what we got? That is what we got, yes? Okay. Do you have to do it this way? Hell no. But if I did put a fifth power, do you see how I could just go 1, 4, 6, 4, and then go one more row, and that would be the fifth power row? Do you guys see that? All right, everybody read this is the third power row. This here's the third power row, yes?
Yes.
1, 3, 3, 1. Fourth power row, I just keep going. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Fifth power row would be 1, 5, 10, 10, 5, 1. Those would be the coefficients in front of all my terms. That's the most I'm going to say about that right now, because Pascal's triangle is not a big part of this. Just very good little tool. Has anyone ever seen Pascal's triangle before by itself? Has anyone seen Pascal's triangle used in this way? No. Okay. Yes.
How come you would, how come would you put the 2 in the middle right there?
What do you mean? Sorry.
At.
Okay. So if you're interested in this, great. This was very, very honest. She's like, nope. Not at all. Okay, that's fine. Do you see how this is all h's, no 2's? All h's, no 2's. The next term should have 2 h's, 1 2. Does it?
Right.
The next term should have 1 h, 2 2's. And the last term should have no h's, all 2's. That's how that works. Okay, again, it just kind of develops a shortcut for foiling things. So if I had an 11th power there, dear God, I'd much rather just play with numbers for a while to get to the 11th row, and then just put all the shit down and be done with it, right? Okay, sorry. So that was somewhat of a sidetrack. We are going to come back to this a little tiny bit in a minute. Okay, coming back to what we're doing. We're given a function. We wanted the slope at 2. That's what this notation is, the slope of f at 2. I might as well say the word, I think I said the word the other day. This is the slope in calculus is also known as the derivative. So we would say this is the derivative of the function at 2. So what does the word derivative mean? Slope, or rate of change, because that's what slope means. So now that we have the components we need to plug into this to calculate it. Do we have f of 2 plus h? Yes. Do we have f of 2? Yes. Jeff did that. It's so helpful. So let me write down this again. So we want f prime of 2. We know that that is the limit as h goes to 0 of f of 2 plus h minus f of 2 over h. And now I can just plug that stuff in there. Okay, let's see. H cubed plus 6h squared plus 12h plus 8 minus 8. I don't know if anybody remembers this. I've said this a couple times, but it was sort of in passing. How do I know I'm on the right track? What's about to cancel? The only, no. They can't cancel it yet. What cancels in order for me to let the H cancel? The only term that does not have an H. That is how you know you're on the right track. If you have a term left alive that does not have an H, that's not good, because then I will never let this be able to happen, correct? I want this to die. I need this to die. Those die first. So what does this become? Yeah, H squared plus 6H plus 12. That's when they cancel an H, correct? And then what's the answer? Let H go to 0 and I get 12. Remind me what that is?
Slope.
Yes, so this is so 12 is the slope of f of x at x equals 2. So the quick way to say all this is f prime of 2 equals 12. So math people, a lot of our expressions or equations are just truncated, long-ass English sentences. We don't want to write all that crap. We just want to truncate it. We don't want to make our own shorthand. Yeah. Say again. No. Tell me this. What's being divided by h? So then everything better lose an h. So this divided by h, it loses an h. This divided by h, it loses an h. This divided by h, it cancels the h. Yes? Yeah. Okay.
Yay.
How do I find the equation of the tangent line then? So I'm at the point 2,8. Everybody agree? I'm at the point 2,8. And we know the slope is 12. Can you find the equation of the tangent line then? Y minus 8 equals 12 times x minus 2 is y minus y1 equals m times x minus x1. If you'd rather do y equals mx plus b and solve for b, cheers. Extra points? No, I don't give a shit. They're both valid ways to do it. You do the way that you remember. So y equals 12x minus 24 plus 8, so minus 16. Is that all right? How do I visually check this? Yeah, if I graph, all right, sorry, so everybody got that? By the way, get used to this question. You're gonna see this question every damn word. Find the equation of the tangent line to this function at this point. That is gonna be a returning problem for the whole damn semester. You're gonna every now and again see it. You with me? Just to let you know. You really should be like, oh cool, but we'll see. So if I put in here, y equals x cubed, and I put in here 12x minus 16. And I also do zoom 6 just to put it back to standard window because I had it in a weird window. Does that look like it does what it's supposed to do? Yeah. I can kind of help myself out a little. Let's look up a little further. So if I hit window, I can go to y max and I can change it. Let's make it 20. And let's go to x max and make it 4. I don't want to look that far up because my x is 2, right? So then I can see this a little better. Did I do this the right way around? Sort of, Jeff. You should have made your y min, x min, sorry. We'll make my x min 0, sure. Now you really can see it. There we go, look at that shit. Yeah. So again, if you hit window, you can control directly what part of the graph you're looking at. So if everything's happening around x equals 2, then I want to kind of like zoom in on that part so I can really see it. So that is exactly what you should see if you're trying to find a tangent line. It should come in, hit right at the point, and then keep going. Okay. Yes? Say again? Certainly. That was an easy question. Yes?
What's after the x equals 2? It's like, y equals 8.
Oh, here.
Oh,
Y equals 8.
y squared.
Yeah, I really want, I'm so excited about ideas, I don't really take the time to write it, so I'm sorry. I'll always do that, because that's just the way I am. Sometimes. Some of my colleagues have fantastic handwriting, I'm like, this is not right, it's not fair. And you're all like, do they teach you? Yes.
Geniuses have that. You gotta question your colleagues.
Geniuses and Jeff. Alright, so I want to go back. If I want to find the slope at a specific input, I can do this. That's section 2.7. Section 2.8 says this. I want to know, oh boy, I haven't given you a break yet. All right, let's take a break. Come back at noon. Anytime I do that, just let me know, because I just keep going. I'm sorry. Let me give you this handout. You all like do whatever you want.
Also, I have a stapler on deck. If you need a stapler.
Alright.
Yeah.
In the interest of time, we're going to kind of sort of do this together a bit. Can somebody remind me what that notation means?
F prime.
F prime, love it. So what is this asking us to do then in English?
Find the prime.
Nope.
Find the slope.
Find the slope at this point. Maybe.
And that would be really difficult. So I'm not asking you to find the slope. I'm just asking you to put them in order, right? So what's the in increasing order? So for example, would you all agree that -7 is smaller than -6? Would you all agree that -6 is smaller than 3? Okay. So put it in order from biggest negative to biggest positive. So a really good way to do this is to kind of like, which ones are positive? Can anyone tell me which one out of this list has a positive value?
3, 2.
Yeah, at 3,
Oh.
let's see, what's happening at 3? It looks like it's very big positive, yeah? So I'm gonna put like big plus. What's happening at 2?
It's like -2. It's
Okay,
0.
here's what I need you to really understand. If I said, what is f of 2? What is f of 2? -2. What is f prime of 2? Do you all see how that flattens out?
Yeah.
-0, positive, so right at 2, it looks to be negative slope. Are you guys with me? That's what's gonna suck. In a bit, we're gonna do graphing the slope given a function, and your brain is gonna like rebel. And you're gonna have to go, brain, stop. So, there is a value at 2, there is a slope at 2, and all I'm curious about right there is the slope. So the slope at 2 is 0. What about -7?
Big negative.
Yeah, you guys see that? At -7, it's going down. That's big negative. You guys see that? I don't care what the value is. It's not what the problem asked me to do. It just wants me to put them in order. Okay, great. I just have to, the great first step would be which ones are negatives, which ones are positives, are there any that are zero? And then I could focus on any that are both positive, both negative, right, to see who's bigger. What about 1? Yeah, 1 is definitely negative, but is it more or less negative than it is here?
Less.
Do you guys see that? Is this going down faster or slower than it is over here? It's going down slower here, yeah? So this is smaller. Do you guys see that?
Yes.
Alright, so what's the order then?
F prime of 1, 0. I know.
The prime of -7, that's the smallest, big negative, right? F prime of 1, because that's still negative, but it's smaller negative. F prime of 2, because that's 0 right between the negatives and positives, and of course,
F prime of 3.
that's the only positive one, didn't matter if it's big or small. You guys see that? It goes big negative, smaller negative, 0, positive. Increasing order. You guys see that? You're going to see something like that in the homework, yes? Do you agree as I approach 2? My slope here is negative, correct? Is what's happening? Is it still negative if I move forward? Is it changing though? How's it changing? It's getting less negative. What is it over here? Positive. So right in the middle, right there, it's got to be 0. Isn't it flat there? So at 2, it looks to be about 0. Yes?
So we're organizing them based on the slope line they're on?
Just the value of the slope.
Yeah.
Where's the slope, bigger, smaller? Yeah. Slope of the tangent line, I love it. Yes. So again, if I say slope of the tangent line, or if I say slope of the function at a point, those mean the same thing. The tangent line is the line that goes through the point that has the same slope as the function does there. That was a lot. The tangent line is the line that goes through the point that has the same slope that the function does there. So the function slope of 2 is 0. The tangent line slope of 2 would be 0 because it's defined to be the line that has the same slope. That's why, does it make sense when I'm doing this weird shit? Tangent line, I'm just following what the tangent line is doing as I move around it. Yeah? So at this point, what's the value of the slope? 0. Positive, 0, negative. Yeah? Yes?
Just imagine the tangent line at, like, straight as you go around it. Like a straight tangent line as you go around.
Yeah, I'm kind of like thinking if something flew off of this, it would fly in a straight line.
Yeah.
So as I move, I'm thinking every point, I'm thinking, okay, what is that straight line doing now? What's it doing now? What's it doing now? What's it doing now?
Yeah.
If somebody flew off here, they would go, Wah!
Right.
Right? Okay.
Yeah, that's what I was thinking to make
Is
sense.
that all right? So I can kind of do this series.
Yeah, that's what I mean.
Yes. That's what I'm trying to do with a pen. Just, yeah, same thing. I like it. So that's the new notation. We all know that means slope now. So whenever you see the word derivative, or if you see this prime notation, you can break it down to meaning the slope of the function. Fantastic. All right, this gets a little weird. The company's profit from selling cars is a function of its advertising expenditure. Oh shit. Does this make sense on the surface? Why? Do you see a lot of ads when you try to watch a YouTube thing? Do ads show up when you try to find mine? They shouldn't. I didn't monetize. Obviously, I didn't monetize. That would suck. Nobody would watch the damn thing. 15-second? No. But there's a lot of ads. Why? Because the more ads they put out, the more money they get. Now, at some point, there's a curve to that. If you spend too much money in advertising, you're not getting more people. You're just losing money because now you're putting too much. So there's kind of like a sweet spot. Does that make sense? So there's a position at companies called the financial analyst. And their whole job is to determine all the different sweet spots. What's a sweet spot now? So every damn day, all the variables are changing, and these poor people are like trying to recalculate formulas based on the new data. Our sweet spot is now this. What's our price point? Set the price to be this, and the next day you find out you were wrong. I don't want that job. That would suck. But anyway, you make a lot of money doing that, but you also lose a lot of hair. So, this is gonna be a little bit weird. P prime, what does that represent? Slope. I like it. What is my input variable? And what does A represent? What does A represent? Advertising expenditure, that's why I use the letter A. What does P represent? Profit. Love it. Okay. So as I change my ad expenditure, I want to see what my profit is doing in response. So sometimes in business class we talk about response variable. Psychology we talk about response variable. Explanatory variable, don't worry, I'm sorry. More than you have to worry about. So P prime, what is slope essentially? The change in Y over the change in X. So the change in the outputs divided by the change in the inputs. So what's weird about the units of this slope? What's the units on profit? Thousands of dollars. What's the units on advertising? Thousands of dollars. So don't they cancel? So it's basically comes down to one way you can show this is money, profit money divided by ad money. Well, the units kind of cancel, but you can still capture the idea. It's the output stuff over the input stuff. Because what is slope? Difference in the outputs divided by difference in the inputs. What would it mean if it was positive? Okay, this is where things get really interesting. Yes? Sorry.
I would have said for 2A, I would have said change in profit per unit expenditure. Is that correct?
Yes. Yes. It's how much so if you want to use more words for it, you could say how much the profit changes given a change in advertising. In this case, I would accept either one because the units canceling is a little weird. So it's more like I've explained it a different way. Right? So, for example, guys, if my input was gallons and my output was miles, what's slope? Input is gallons, output is miles. Miles per gallon, right? Because they didn't cancel, that's an easy one. Miles per gallon, I'm done. Here, thousands of dollars, don't they cancel? Oh shit, so I gotta come up with a different way to say it. So that works too. Now, what does P prime mean? Sure. What's it mean? So, if the slope of a function is 2, if my x changes by 1, my y changes by 2. Good, so now we understand what P prime means. If I change the input by 1 unit, I'll change the output by whatever the value is, right? So what would it mean if it was positive? If I increase the ad expenditure, what should happen to my profit? It should go up. So if you calculate it, if you're the financial analyst losing hair as variables are changing all around you, and you calculate P prime and you get a positive, what are you going to recommend? Increase ad expenditure. Does that make sense? So this is exactly, now the functions they use are complicated, but this is exactly, they calculate it, okay, increase. Now of course they drill it down to increase it by $35,000 in this sector, right? They get more detailed, but still, it's the same stupid thing. If the slope is positive, in this case, if I increase my ad expenditure, profit should go up. We know that's what a positive slope. So if it was a negative, we want to draw back some ad expenditure, right? And if it's 0, no. Not P is 0, P prime is 0. Say, no. If I increase the ad expenditure, it doesn't change at all. So that means I hit the sweet spot. I'm at the sweet spot. If my P prime is 0, that means if I change advertising at all, I don't affect the profit at all. So I've hit my sweet spot. Does that make any sense? Yeah, you hope at the maximum. You're a good point. So if you're down here, you're like, well, shit. We got to really move it far over. Yeah, okay. All right, so what would it mean if P prime of A was positive? Increase in ad spending means profit goes up. That's what that collection of symbols says. Increase in ad spending means profit goes up. Now I bring this in, so now I get much more specific. What does this statement mean?
$500 and $500,000.
So what are we currently spending on ads?
500,000.
500,000. So current ad spending is $500,000. Everybody see where that came from? Because these are measured in thousands of dollars, and the input is advertisement spending. Yes. Okay, I like it.
Wait,
Go ahead.
P prime 500 equals 20.
So the 500 by itself,
Right.
the 500 by itself is the advertising. Yes.
Mhm.
So that I can pick that off immediately. Now I can step out like you're doing and go, okay, the rest of it is, when my ad spending is that, what does this mean then?
The rate is increasing.
Slope is 20, so my profit would go up by 20,000 if I increase my ad expenditure by 1,000. Let me make sure you guys are ready. What are the units on this?
20,000.
What are the units?
$1,000.
Profit money
Profit.
over ads. So if I increase, what's on the bottom? Is it 1? So I increase my advertising spending by $1,000. I predict my profit to go up by $20,000. You guys, does that make sense by itself?
Yes.
Okay, so at the point 500, the slope is 20. If it were a straight line, wouldn't that mean step in 1 here would be a step in 20 there? Isn't that what slope means? If my slope is 20, if I change x by 1, how much does my output change? Frickin' 20. Isn't everything in thousands of dollars? So if I increase my ad revenue by $1,000, I predict an increase in profit by $20,000. Now, one thing I want you to realize. Oh, go ahead, sorry.
Where did you get the $1,000?
Okay, you agree with me that if my slope is any whole number, I can put it over 1. Why does that make sense in general? Because slope is defined to be a ratio, correct? And we define what that ratio means here. Isn't this how much ad money? The change in ad money, the change in profit. So if I increase my ad money by 1,000, why increase? Because it's positive. My profit will go up by 20,000. That's what, if I change this variable by 1,000, I'll change this variable by 20,000. That's what that means. And you all know that's what slope means. You just don't get to talk about it in real life terms very often. Maybe your algebra teacher did that a bit with you. And maybe you're like, I don't remember algebra at all. Okay, I understand. Okay. Is that better? I was about to say something, damn it. What did I forget? Oh. So when we're spending $500,000, if we spend 1,000 more, profit goes up by 20,000. If we spend $1,000 more, we predict our profit to go up by 20,000. Are you with me?
Yes.
So if if the slope would have been 5, $1,000 more spending, I would predict the profit would go up by 5,000. What if this was negative 10?
They lose 10,000.
We'd lose 10,000 for every 1,000 more in advertising. So that's when we would actually pull some money out of advertising, maybe. You guys see what I'm saying? When we oversaturated the market with our message, and everybody's like, "We got it." So by putting more shit out there, we're not gonna get more people. Yeah.
Is that what happens if we dislike an ad?
Oh. I have no idea if they actually look at that at all. Who knows? By the way, I really hate business. This is the most I'll ever talk about business. I am so not. If you're a future business owner, fantastic. You do that shit, right? I'll do this shit. Okay. I'm sorry. Nothing wrong with business. Somebody's got to do it. Does that make sense? Again, this is stuff you guys came in knowing. You just haven't necessarily looked at it this way. Suppose a company plans to spend about $500,000 in advertising, right? And we know this statement from just a second ago. And we already said this. Should the company spend slightly more or slightly less than $500,000 in advertising? slightly more. So anytime the P prime is positive, I should boost my advertising. Now listen, the minute I go away from 500, I want you to understand, this profit curve, isn't it a curve?
Yes.
The minute I move at all, doesn't my slope change? I need you to really get what I just said. So if I change my advertising by 1,000, does that mean I'm going to definitely make $20,000 more? No. Because the minute I change anything, that's not the same number anymore. I've moved a little bit, correct? So that's why they're always kind of like, do this change, now let's see what happens. Do another change, now let's see what happens, right? You don't want to change too many variables at once because then you're not sure which one did what. Yes?
On a test, you would call it a curve, and that would imply that it's changing.
Well, math people are weird. We call a straight line a straight curve sometimes.
Right.
Because
You're
we're
making it very
special.
obvious that one's straight and one's not, right?
Yeah, I mean, yeah. All right, so we basically already answered part D. More. Okay. Oh, number 3 should be a quick one. Let's see if you guys agree. What algebraic letter, symbol, could I use for this? M. This is a freaking slope, yeah? What point does my function go through?
3, 5.
3, 5. Does my function go through the point 3, 1? I mean, sorry, 3, negative 1. Does my function go through the point 3, negative 1?
Yes.
That's what my slope does at 3. This is the only thing I know about what my function is doing. This is what my slope is. So be very careful. Do you guys see the prime? You got to be nice to yourself. We're getting there. We're getting to a point where we're going to have f of x, f prime of x, f double prime of x. And you're going to have to use different ones at different times. And the nicer you are to yourself, the easier that's going to be. So what is this question really asking you? This is a very calculus question. But we can make it algebraic easy. Find a line going through 3, 5 with a slope of negative 1. Okay, do it. I'll wait. Do it. So we know the slope is negative 1. We know we're going through the point 3, 5. Find the equation of the line. You got 2 main ways you can do that. Yes?
So, when y is 3, the slope is negative 1?
No. When x is 3, right? X is the input. The slope is negative 1. So at this point, x is 3. At this point, the slope is negative 1. It's going down 1. At 3. So the slope is negative 1 at this point.
The slope is negative 1 at 5.
At this point.
Oh, okay.
So I did one earlier with the y minus 1, 1. I'll do one with y equals mx plus b just because. So I know y is 5 when x is 3. I can then solve for b. And then I just put everything together. Is that all right? You can do it that way, or you can do the y minus y1 thing. Either way. Okay. Yes?
Would you mind doing the second one?
Say again?
Would you mind doing the second one?
Let's find out. Y minus what?
5.
The y piece, good, equals m times x minus the x piece. Y minus 5 equals negative x plus 3, add 5, and I still get negative x plus 8. Is that all right?
The prime makes way
Kicking
more
ass.
sense
Huh?
now. The prime makes way more sense now to me. It's just like,
Sweet.
oh,
That's all it means. And again, it's just almost every symbol you see in mathematics. Has anybody ever seen the symbol we're going to see later this semester? Has anybody ever seen this collection of symbols?
Yeah.
All right. Some of you guys know what this means. A lot of us don't know what it means. Okay, the minute we find out what it means, it'll be that much easier, right? Right now, this is literally, well, so, anyway, we'll get there. The history of the symbols is really funny to me, but you'll see what we get there. Okay. So, in section 2.7, you'll see some problems that look like this. They want interpretations of slopes, and they want looking at a graph, can you tell kind of like what the slope is? Yes? So look at the other side. This is where everybody, okay. This is where your brain is going to rebel. Okay. That's on the thing, Jeff. Okay. Now, before we do anything, what's true about the slope here? Until about when? About -2 points something, right? You guys with me? I don't care what it is exactly, but you all agree with me? It's increasing until then. What is happening to the, it's really big positive here, is that cool? It's almost straight up and down here, right? What's happening as I get up here? Small. So whatever the value of the slope is at -6, would you agree that it's smaller at -4?
Yes.
Until it gets to what?
-3.5.
Until it gets to here when it's 0. Are you with me? So here is why your brain is going to rebel. We need to graph f prime. This is f. What ends up happening is people start to just trace the f. That's not good. Is f negative or positive? Is f negative or positive here? Negative. F prime is freaking big ass positive. So at 6, I'm going to be way the shit up here if I'm graphing the slope. You don't have to calculate the slope at every point. You just have to know, like we did earlier, is it big ass positive? Is it small positive? Is it 0? Yeah.
So basically you're drawing the graph upside down?
No, hell no. Definitely not. I'm drawing the graph of the derivative of f. Whatever f is, we're going to draw the graph of it. Do you all agree with me that we could do the limit as h goes to 0 of f of any specific point if I knew what the function was, correct? What I'm saying is, if I did that for every damn point and then plotted the points, we would get a picture of f prime. We're going to skip all that stupid shit and we're going to get a decent sketch of it. Can anyone tell me where is the, we already said this, but where's the slope 0? Give me one value where the slope is 0. One x value. Yeah, like right here, right?
Yeah.
If I am plotting the slope, everything I'm about to do is going to be the value of the slope. So at this x value, you just told me the slope is 0, so I'm going to put a point right there. Does that make sense?
Yes.
Everything I am about to do represents what the slope is. Is there another place I could do that for?
Means 2.5
Like right here.
-1.
About right there, is that cool?
Yeah.
So I just identified where my tangent lines would be flat, where the slope would be 0. Are you guys with me? Is everybody really with me? That's a really great place to start. Give yourself what I call anchor points. So if you start to do weird shit, these points might go, you're supposed to be here, man. Where are you going? Oh shit. Okay. So remind me, this was really big. What slope here is really big? So if I'm graphing that, I'm going to start way the shit up here. What happens as I get closer to this point? The slope gets smaller. Yes? So let me just do this. Then doesn't that represent what we just said? It starts off really big positive. Isn't this really big positive over here?
Yes.
And then it gets smaller and smaller. The slope gets less and less. Is the slope positive at every point before this?
Yes.
Yes, it is positive. Isn't this positive at every point before this? What happens to the slope right past this? Yeah, right past this, it goes negative. It's not very big negative at first, and then it gets more and more negative. And then down here it's going to get less and less negative. Do you guys agree there's a spot in here that the slope is the most negative? Because at 0, starts to grow more negative, and then it starts to shrink to less negative. So somewhere in here is the lowest negative it'll be. That sounds like the vertex. The slope is going to go negative here, yes? I'm going to go down below. And somewhere in here is going to be the most negative it could be. Because what's it do after this? What's it do here? Doesn't it start to get less negative?
Mm-hmm.
Okay, so it's going to go more negative. Somewhere around here is going to go to the vertex. And then it's going to get more, let me say this again, less negative until it gets to here. So let me try this again. You all agree that from here to here, it's a negative slope, yes?
Yeah.
It's not very big negative yet. Then it gets big negative, and then it turns around and gets less negative. What happens forever after this point?
So it's back positive.
It's positive and it's getting bigger and bigger positive, yes?
Yes.
What does that look like, the graph I just made?
Right.
Round. What does this look like?
Sine.
Yeah, that looks x cubed. That's some kind of x cubed. And what we just graphed looks some kind of x squared. Yes? Interesting. Interesting. Yes?
You said that the slope's increasing, it's kind of gone flat, so that's why we drew it opposite.
So after this point, the slope starts to get, the slope is positive, yeah?
Yes.
And it's increasing as I move along. So this is going up, increasing.
The middle part, what did you
Say again?
say? The middle?
In between this and this is the slope negative or positive. So in between this and this, my slope function better be negative because it's supposed to capture the value of the slope. Okay, maybe. Until you guys try this on your own, some of you guys will actually start to do what I said you're going to do. You're going to start to follow the function. You got to go, wait a minute. Yes?
So the slope is positive at the beginning, but the parabola one has a negative slope.
Oh, no, okay.
It's like the y.
That would be the slope of the slope. So we're going to be careful. So this guy's slope doesn't mean shit to me for this problem. I could then say, can we graph this guy's slope? That would be another problem. Does every point on the line I drew, does it seem to capture the slope of the original function? This point is positive. This point's positive. Move a little forward, it's still positive, but it's smaller. Move a little forward, it's still positive slope, but it's smaller. Do you guys see what I'm saying? Here the slope is 0, here the slope is 0. Here the slope is negative, here the slope is negative. Do you see what I'm saying? The slope of this line would be a second derivative. It would be a second slope. That's not what I'm asking about. I just want the first derivative. I want us to capture what the slope is doing for the function I gave us.
When you say the second one is positive, what do you like? How?
Do you agree this slope is positive?
Yeah.
Do you agree that the point I graphed here is positive? The output is positive.
Because of the y, like the y value.
Totally. So f prime of x, what do the outputs represent? What does prime mean? Slope. Therefore, if I'm trying to graph f prime, the outputs better be the slope at that point. And what you're doing right now is sort of like, what you're doing is interesting because I never really heard that kind of thing where somebody went further. What people normally do is they say, well, this is negative. Why is this up here? No, the slope is positive. That's what I'm trying to capture, right? Sure, the function values are negative. Who cares? Yes?
So for the second line that we made, it doesn't really matter what the points are. We're not looking at that thing.
Yeah, I could get more specific and I could try to estimate the slope at some
It's
points.
just a display of what the slope is at that point.
A rough estimate of what the
Yeah,
slope is
so
at that
like
point.
-6, where whatever the slope is on the original line, it's displayed in the new one.
Exactly. So is this the exact right answer? No. Is that what I want anyway? No. This is more of a conceptual thing. I don't need the exact right answer. Yeah. Okay. What's weird about this problem? Is the slope changing as I move along? No. Can somebody tell me what the slope of this is? Now on this problem, I want to know what the slope is because it's easy. It's just a freaking line. What is it? -1. So at this point, what's the slope? So I'm going to graph -1 right there. Jeff, you have to turn the pen on there. At this point, what's the slope? Holy shit. So what's the slope going to look like all the way up until here? Straight line. Why is it a straight line? Because the slope is not changing. So of course the derivative, if I graph it, is going to be a straight line. Now right at this point, all right, let's do this side first, then we'll talk about this point. What about this side? 1. Slope is 1. Now what do you think is happening right here? Is there a slope right there?
No.
Hell no. So I put an open circle and an open circle. We would call this, does anyone know what the function is? You should. So for the absolute value of x, it is not differentiable. You cannot find the derivative at 0. Because when I graph the derivative, is it continuous through 0? No. So therefore, it's not differentiable at 0. It does not have a slope at 0.
So that's why, above and below, they don't continue.
Yeah, back here it's a negative slope, and then suddenly it transitions immediately to a positive slope. Is this a plane you want to be on? No. Welcome aboard, everybody. Oh shit, we're gonna. We are dead. We are dead. Right? If I turn this around, is that a mountain you want to try to lie on the top of it? No. Okay. Yes.
The limit exists though, right?
Yeah, the limit of the function exists. Does the limit of the derivative exist? Hell no. Is it continuous? No. The derivative is the function continuous through 0. Yes. Is the derivative continuous through 0? No. Yeah.
Why did you choose to draw the lines on 1 and -1?
Because the slope isn't the slope down 1 over 1? Isn't the slope -1? And this is why this problem, I should have put this problem first. I am literally trying to capture the value of the slope. Now, in that problem, I'm going to let us be a little more loose because I don't want you to sit there. You could estimate the slope here by picking 2 points near it and trying to do it just like section 2.1. I don't want us to worry that much about it. Here, it's very easy to tell what the slope is. All right. So let me see if you guys are cool with this. Where did we start first here? 0. So, but there's a couple of places here that are pretty easy. Yeah.
Sorry, going back to 1, on a test, are you going to allow the same level of leniency? Like,
Oh, hell yeah.
as long as it's like the general shape. Then
Yep.
it'll be good.
Yep. In fact, what we're about to learn today will really make this thing make more sense. Anytime I have a cubic, I should get parabola when I draw the slope. Anytime I have a 4th power. You guys know what a 4th power might look like?
It's a wiggling.
Yeah, it could have a little butt. Call it a little butt wrap. So if I do the slope for this, I should get a cubic. It should always be 1 degree less. And we're about to learn today that's what the math does. We'll see why it does that. I'm hoping. Okay. Where's this function? So we can do this a couple different ways. Where's this function easy? Where's the slope easy?
-5 and -2.
Huh? Like here, this is a straight line, correct? What is this guy's slope?
Negative. Or 1 point is positive.
Yeah, you guys can do this. So isn't this a point it definitely goes through?
Up 3 over 2.
So it looks to be up 1, 2, 3 over 2, 11. You guys with me? So from here to here, where would I put my line to represent the slope? You just told me what is the value of the slope for this whole section. What's the value of the slope? Up 3 over 2, so it's 3 halves. So aren't I going to draw a line? What's 3 halves also known as? 1.5, 11. So I'm going to draw a line right there, 1.5. That line I just drew represents the slope of that part of the function. See how I put a little open circle there? Because some weird shit happens right there, yeah? That's another thing we call it a kink. You ever used a garden hose and you kink it? And you wait for somebody and then you unkink it when they look at it? Okay. Now this next part, where's a good place to start there? Where's it 0 slope? No, be careful. At 0. Look, where is always x? So it's 0 at 0. Sorry? What about -1? At -1, it's just got a big negative slope, yeah? So what is true about the slope starting here? What's true? Is it positive or negative?
Negative.
Negative. And is it getting bigger or smaller negative? Because eventually it's got to go to 0, right? So it's kind of big negative, and then eventually it's got to go to 0. So watch. This starts off big negative. Okay, big negative. It's less negative, less negative, less negative. Okay, less negative, less negative, less negative. So when you look at the function, it's what it is doing. When you're graphing, it's the values of that. So what's the function doing here? Going down pretty steep. Okay, so I'm going to make a big negative number. Less steep. Okay, I'm going to make a less negative number. 0. Okay, I'm going to go to 0. And then what's it do after that? Up until 1. Yeah, now it's gonna go positive, yeah. Until it's at 1, so it just doesn't really matter exactly where it goes. Okay. To be really honest, it should have been a straight line, but it doesn't matter. As long as you show me, you know it's increasing. It's negative and then it's positive. That's what's important. What happens here? What's beautiful about this part? This whole thing is the slope of what?
0, 0.
So from here to here, it's the slope of 0. Should be open circles. That's okay.
Open circles.
Yeah, because right at this point, the slope is undefined. And then what happens after that? This piece is nice. Why is this piece nice?
Positive, it's 1 over 1.
Yeah, it's got a slope of 1 from here to here. Crazy shit. Yes.
You said where it's undefined, but the colors.
Say again. Sorry. Yeah, there should be an open circle there. Yeah. Yes.
So would you say like, since it's up 1, right 1, would you say that you just draw like a straight line type thing?
Where are we at? Sorry.
Like 3, 4.
From here on this part.
Yeah. So
The
since
slope
that's
is
up 1,
constant
that's
here, right?
Yeah.
And it's constantly 1, so I'm just going to draw 1.
Yeah. Okay.
Yeah, if this was steeper, I might have drawn 2. So every place on that blue line I'm drawing must be the slope of the function at that point. So when I have a straight line that kicks ass, it's just going to be a constant slope. Yeah.
Is this the one I asked you the other day, when if it's, what they call it, if it's sharp and it's straight, then it can't be continuous?
Yeah, it's not differentiable there.
Okay.
So the original function here, is it continuous there?
No.
Try again.
Wait.
Is it continuous? Do I have to pick up my pen to do that? No, I just have to make a short term. Is it differentiable, which is a new word?
No.
Another kind of way for derivative, if I want to find a derivative, I could say differentiate this. That means find a derivative. Is it differentiable there? No. Because the derivative would be discontinuous there. Doesn't the slope change very suddenly? Again, a plane I do not want to be on. I want my plane to have slopes that don't change so suddenly. Please, dear God. Yes? Maybe. And again, it's a little bit of a preview. We're not quite there yet, but I might as well talk about it. What's different about number 2? What graph do I give you?
The derivative.
I give you G prime. And then I ask you to sketch a possible. But now, let me ask you this real quick. I should have asked you this earlier. This is a good one to do this on. What if I picked that whole picture up and I moved it down to here? Would that change our graph at all? If I pick that whole function up and I just move it down to here, do these lines change? Do you see how the slope did not change worth shit? So I could pick this whole picture up and move it up and down as much as I want to, and these stay right there. The slope is 1. If I shift the whole thing down, isn't it still 1? Okay, I like it. So think about what that means backwards. What if we know the derivative? Do we know where it is? If I tell you the slope of a line is 3, can you draw the line that I have in mind? No, you can't. Nobody here can. Because trust me, what y-intercept does your line have? It's not the same as the one in my head. So if I tell you the slope of a line is 3, all you know is, if I go over 1, it goes up 3. That's all you know, correct? Do you have any clue where the hell it is? So if I just tell you the slope, is that enough information to know where it is? No. So here, I tell you the slope. So what do we know? What's the only thing we know between -5 and -2? What's true about
It's constant.
slope is 3. Be careful. This is G prime. And we're going backwards. So this is where, in your head, it's kind of like doing the manual transmission and you go, you got to go backwards and forwards. So now this is G prime. The picture you see is the slope. So what kind of picture am I going to draw between -5 and -2? It's got to be a line that has a slope of 3. So I'm going to start down here so I have room. So just what I just said, it doesn't matter where I put it, as long as it has a slope of 3. So if I start here, I'm going to go up 3 over 1. Is everybody with me? I have a slope of 3 so far, yeah? Do you see why I want to start way down? Up 3, over 1, up 3, over 1. There we go. Here's one possible answer, yes? Yes.
How come it's 1 though?
Say again?
Like, this straight line, how is it 1?
No. This being G prime tells me the slope is, what's the slope? In between here, what's the slope? This is G prime. What's the slope?
1?
No.
G3.
3 over 1. Anytime you have a whole number, don't you put it over 1 when you're talking about slope?
Okay.
Of course you do. It's not over 0. That's some weird shit.
Okay.
Okay. So up 3 over 1, up 3 over 1, up 3 over 1, because I know it's the slope of 3. Then I go to this one. What's the slope supposed to be here? 0. So to be honest, I could just draw it right on top of this thing, but just to make it a little more clear. So I just want a line from -2 to 1 that has a slope of 0. That's all I need. So where can you put it? Anywhere. I'll tell you where to put it, Jeff. Be quiet. So I'm going to put it here just because. I don't think anybody did. What's got to be true about the line segment I draw from 1 to 3? Slope of -2. So if I start here, it doesn't matter. I need you to see. All that has to be true is that the slope is -2. You can start wherever the shit you want to, but I'm going to start up here to make sure I have room. So then I go down 2, over 1, down 2, over 1. Are you guys with me? That's unfortunate because I ran into that guy, but we'll be okay. Does this line I just drew have a slope of 2? I'm sorry, -2.
That's level 1.
Huh?
Oh, the next one.
This line right here that I just drew, does it have a slope of -2?
Yeah.
Yes. And that's what it's supposed to be, yes? What's supposed to be true here between 3 and 4? Slope of 1. So I can start right here if I want to. Up 1 over 1. How many answers are there to that question? Infinite. Bazillion's a pretty good estimate. Okay. Weird, yes? And this is an example of math that sometimes just has to click, which as a teacher is really frustrating because it almost is independent of how I describe it. It just has to sort of click. Okay. So again, this is the slope, yes? I'm going to remind myself this is the slope. So what's true about the slope? Now, here's where things get more interesting. This was easy because these are all constant slopes. What's happening to the slope? It starts off,
At 1. Starts off
yeah, it starts off as positive, then there's a 0 here, then it goes negative. So what shape can I make between -5 and -1? It's got to have a positive slope, then 0.
Oh,
Can you guys do that in the air? It's got to be positive slope, then it's got to go to 0, then it's got to go negative.
Yeah.
Isn't it going to look like
Oh,
down parabola? Yeah. So I'm just going to put it up here so I have room. So it's got to start off positive, then 0, then it's got to go negative. Where am I going to? -1. There you go, Jeff. And here, this is the easy part. What's got to be true about this slope?
It's gonna be constant.
Yeah, it's got to have a -1 slope, yes?
Yes.
So there's no reason I have to connect these, but I just am. So down 1 over 1, down 1 over 1, down 1 over 1. Okay. Did you do that right, Jeff? Maybe, yes. And then what's got to be true about the slope between 2 and 3? Let's see if you guys are cool with this. Be very careful.
So up.
No.
We know upper.
What are the values here? Are they positive or negative?
Negative.
And this is a graph of the slope. So my slope must be negative.
Then it goes.
Then what happens at 3?
So it's kind of.
It's 0. So it's negative, then it's 0,
Then it goes back. And then it goes positive.
then it's positive. So I can just do that, just to make it neat. That looks like the Big Dipper. Now, not only can some of you guys see how somebody can get confused, some of you are at the moment confused. I understand that. I'm hoping you can see, you just have to keep reminding yourself, what is it I know? In this case, I know the slope. In this case, I'm trying to draw the slope. Yes? Yes.
For number 2, the other number 2.
Up here.
Yeah.
Oh yeah, I love it.
What
Just showing off my counting skills. Go ahead.
What were the values of X. What's the answer to the question?
The drawing here, I'm sorry.
The-
Oh, I'm sorry, I forgot there's a whole other thing. Which values of x is h not differentiable? Where is my slope discontinuous? My slope is discontinuous at -2, right? Where else? 1 and 3. So where is something not differentiable is where is the derivative discontinuous? That's why an absolute value has an obvious not differentiable place, because the slope abruptly changes. Yes?
Is the beginning of the, prime and then one and through on top, does that have to say beginning and end? Like,
No, it doesn't. You mean down here? I tried to say it when I was making the decision, like right here, I could have put this whole middle line, I could have put it down here.
But on the x-axis, would you have to follow the point, like -5?
Yeah, the slope has to constantly change according to what these say. Yeah. But at this transition point, I could have moved that somewhere else entirely. Could be a piecewise. Okay, but you don't have to. Keep it straightforward if you want to. Alright. Good. We're not done, guys. I don't know. You guys sound like you're getting packed up. I love you guys so much. Let me do this. I'm gonna give you the practice test. We're going to talk a little bit about section 3.1. I'm going to prove one thing. How long is it going to take, Josh? And then we'll leave. So please just kind of glance at this and then put it away. I'll have the answer to you tomorrow.
So tomorrow's review.
Yes. Well, part of tomorrow's review. No, this is a lot longer. Practice test, I'm gonna give you the answer tomorrow. I never need to see this. You don't have to do this at all. You make it out into a paper airplane. Notice it, this is just a study guide. The most important thing is homework. This is to show you what kind of questions I like to ask, for example.
This, he printed out the practice test for us. This thing's gonna be on that.
Oh, I didn't know.
There's no first test. Not exactly, yeah.
The other state is gonna
I put it in Canvas, so I actually did print out one for everybody. So whoever that is, let her know she can see me or get it from Canvas. Did anybody notice I put the practice test in Canvas? I love you guys so much. So there's a way, if you go to Canvas, at the very first page, at the bottom it tells you how to turn on notifications. So anytime I add something new, you'll get a notification. If you want. If you don't want to know those kind of things, you don't have to. Okay, so then this guy. Let's do this. Alright, just to get you guys a little bit excited about what we're about to do. We're about to start proving what we need to prove so we can stop doing the limit definition of derivative. Does anyone have an idea what the limit definition of derivative is? How have we been finding derivatives so far? Sure, that's the symbol for it. How have we found the slope at a point? Good. Limit as h goes to 0, f of x plus h times f of x over h, right? And that is just y2 minus y1 over x2 minus x1. Oh, yes, Jeff. Good, you should be like that. You should be, oh, this is old news, yes.
Whereas with the regular original difference quotient, it would be minus f of h, right?
No, this is it. There is no minus f of h.
No, not for the limit of the derivative. I'm talking about the one that we learned previously. It would be minus f of h, right?
Nope, never. I'm not sure what that's all about, but if you find something, show it to me.
Okay.
Yeah.
Sorry, is this 2.7?
We're jumping in, no, we just did 2.8,
Oh, we did that was the word.
Oh, I see.
and now we're gonna jump into 3.1. Yeah. Now, just to let you know, 2.7 has got some graphic stuff, but it's mostly about finding the slope at a point. So it's like the very first problem we did, f of 2 plus h minus f of 2, that one. 2/8 is finding the slope everywhere. So doing this, not with a 2 or a 3 there, but just this.
But
Okay.
using graphs.
No, using this. And it's got the graphs in there too. So it's got both. So 2/8, it's got the graphing stuff, and it's got this.
The 2/8 was just graphs.
That was on my handout, because we've done a ton of this already, so I didn't need to give any more examples. Yeah, we've done this already. So, earlier today we did something with this. We did it at a specific point, correct?
Yeah.
So I want to very quickly, I want to just do it not at a point, I want it everywhere. I just want to know what f prime of x is, period.
That's what you do.
I want to find f prime of x. So what that means is, I'm not going to plug in a specific point. We're going to do the same work we did earlier. And I'm going to show you how we can truncate it a bit. We've already kind of shown a shortcut for it. So this would be the limit as h goes to 0. Okay, keep going for me.
F x plus h cubed, but no. X plus h cubed
Yeah, so plug in x plus h into f.
minus f.
What is f of x?
X cubed. Okay.
Good, okay. Didn't we just develop a shortcut for this guy? Let's see if you guys are cool with this. And again, you can write it 3 times and FOIL it out, that's great. If you're like, I will never use Pascal's triangle. So I want to put 11 there, have fun. That's okay. So this would be 1x cubed, no h's, plus 3, remember 1, 3, 3, 1? Plus 3, 1 less x, 1 more h, plus 3, 1 less x, 1 more h, plus 1, no x's, all h's. That's how that works, that kicks ass. So if you wrote x plus h 3 times, did all the work, you'd eventually catch up to us here. Minus, so that's all of this, is everybody with me? Minus x cubed, and how do I know I'm on the right track?
No, the ones with no
The
h.
only ones that have no h die. So then what am I allowed to do? I'm going a little fast, and that's okay. And you're all like, yeah, Jeff, you always do. Okay, slow me down.
Yeah, take out h.
Every term gets divided by h, so basically every term just loses an h. Is that cool? Can we stop for a moment? It's exactly the same stuff we did earlier, we just don't have a number in there, we just have x. So what I'm doing is, I'm developing a function so that if I plug a number into the function we're about to develop, I get the slope of f at that x value. So instead of doing it for 2, now let's do it for 3, now let's do it for 5, now let's go insane. No, I'm just going to do it one damn time, and then I can plug whatever the hell point I want to into it. I'll have a function that actually gives me the slope. I just have to plug a number
That's what
in.
the derivative is.
That's what the derivative is.
So, a way to think of it, would you look at the exponent and then that's how you know, oh, okay.
We're about to get there. We're going to get there.
No, but like just to start, like x cubed minus 3x, where you just look at the exponent and be like, oh, okay, I started with x cubed and
Oh, sure, yeah. If this is the 4th power, this will be x to the 4th.
Okay.
Plus 4, x cubed, h, yeah. And that's where you need Pascal's help to know the coefficients, right? All the Pascal's triangle does is it tells you these coefficients, yeah?
Mhm.
Or you just write the damn thing down so many times. So if I let h go to 0, I'm allowed to do that now.
3x squared.
Didn't we cancel this guy,
Yeah.
right? So I'm allowed to let it be 0. Yes, so what do I get?
3x squared.
So I started with x cubed, and the derivative became 3x squared. Do you remember earlier I said when you have a cubic, you should end up with a square if you start to graph? So if you have a cubic, you should get a parabola when you're graphing the slope. Okay. What does it look like happened?
You brought the 3 down and the power.
So I brought the 3 down, and the power went down by 1. Yeah? So, let's develop our very first rule. So this is us getting away from doing this. Do you want to do this if it was an 11th power? Holy shit. So we want to make a shortcut, yes? Okay, so the way I'm going to make a shortcut is I'm going to start with the most general possibility. X to the n. So now to find f prime, I've got to do this. Are you guys all with me? So instead of a 3, I have an n, yes?
Just the exponent.
Okay.
So that's the power, is that what's going on?
Sorry?
That's n is the power?
Yeah, instead of a 3, I have an n. So what could n represent? 3. It could represent 11. It could represent 18 billion, right? So if I do this, for this, I have a shortcut for any damn power somebody puts there, yes? That's the idea here. So we're gonna use limit definition to develop shortcuts so then I don't have to use the damn limit definition every time. Yes?
Would you be able to use it for previous chapters or no?
What do you mean? Oh, no, hell no. So any math class you take, if you're in section 2.7 and you try to use something you learned in 2.8, no.
Yeah.
That ain't gonna fly. So very often I'll have people in calculus use something called L'Hopital's rule. Does anyone know L'Hopital's rule? Alright, if I see any of that shit on the homework for chapter 2, oh, because we don't know that yet officially. And you're like, well, I know it. And I'm like, here you don't. Too damn bad. Yes?
Sorry, so that's x plus h.
Yeah, so if f of x is x to the n, what is f of x plus h? X plus h to the n.
Yeah, I just wanna make sure I can tell
Yeah. My awesome, no, you have nothing to apologize for. It's me that has to apologize. Alright, now watch. Now listen, you guys, x plus h to the 11th power would be gross. X plus h to the nth power, what the shit? Yes? Do you all agree with me, from Pascal's triangle, the second term seems to have the power in it? Yes, the power is the coefficient, yes? Third power was a 3, fourth power is a 4, yes? So, if I were to multiply this thing out, does everyone agree with me that the very first thing I would get would be x to the n? If I wrote x plus h times x plus h times x plus... If I do all the FOILing, I'm going to end up with x to the n at first. Now, using this, if I went down to the nth row, it would be 1n, blah, blah, blah.
Yeah.
So the next coefficient will be n. I'll have 1 less x. Is that cool? 1 less x. And I'll have 1 more h. That's exactly what we did earlier, right here. All x's. 1 less x, 1 more h. 1 less x, 1 more h. 1 less x, 1 more h. Yeah. I'm not gonna sing or dance because I'll show you why I'm a teacher. Alright, so everybody semi with me right now. So this is like a 3 for x cubed, this will be a 4 for x to the 4, so x to the n, this will be an n. There'll be some other freaky ass terms. Can anyone tell me every term that comes after this, will it have less h's or more h's? Every single time I'm gonna get more, I'm gonna lose an x, gain an h. Every single one of these terms is gonna have at least how many h's? 2. The next one I have h squared, correct?
Oh, yeah.
You guys all with me?
Yeah.
So every freaking term after this one has at least h squared. So plus h squared shit. Right? Minus x to the n. Y'all with me?
Yeah.
Why can I just do that? Why can I just write h squared shit? Because these cancel, correct? Then what do I do?
You divide an h.
By h, and what did I leave out of here that's really bad?
The share.
Yeah, the limit. So if I cancel the h's out, this will have at least an h, and everything here will have an h in it, at least, right? And then I'll let h go to 0. So let me make sure everybody's moving. No h's, 1 h. Everything after that has at least 2 h's, yes? H squared is cubed. So when I cancel these and I kill an h, this has at least an h in it. So this whole thing, when I let h go to 0, this whole thing's gonna go to 0. Every term has at least 1 h in it. Go ahead, yeah.
So it says, at the end, it says minus x to the h, or is it x to the
X to the n, yeah. Yeah. Okay. So what does this limit come out to be? What's the only thing left alive? So let's make a rule out of this. If I start with x to the n, my derivative is n times x to the n minus 1 is exactly what we thought it was. This kicks so much ass. So if I have x to the 8th, what's the derivative?
8x to the 7th power.
8x to the frickin' 7th power, yeah. Alright, what if I have g of x equals 11x to the 4th? What do you think g prime is?
44x
Good.
to the 3rd.
Alright, I'll calm down. It's 11 times x to the 4th derivative, right? So it's kind of like, whatever number's out here, I'm finding the slope. So if there's an 11 out there, the slope's going to be 11 times as big as it normally would be. So whatever number I bring down, I just multiply by whatever's there already. Yes?
Paper.
Yeah, any damn time you want to. So, let's see, there we go. Alright, so let me give you this. It's basically got exactly what we just did, just written a little better. Well, a lot better. No, we'll have questions at the beginning, and then, yeah. But I'm not gonna design it to take it the whole time. It's only 25. And when I say 25 questions, I'm counting all the A, B, C, D. So just very quickly, I want to point out a couple things. I know you guys are so used to being gone by now, but too bad. So here's something new. This we understand here, right?
Yes.
This is another way to write it. This notation is actually better, even though it takes longer to write. And you'll understand, does anybody have to, how many of you guys have to go to Calc 2? How many of you guys have to go to Calc 3? Just to give you a little preview of Calc 3, Calc 3 is going to be where you have a multivariable, it's the whole point of it. So you're going to have an expression that has 5 variables in it, and they're going to say find the derivative, and you're going to say derivative according to what variable. So this notation tells me I'm taking the derivative of f with respect to x. X is the variable. Is that necessary in Calc 1? In a couple places, yes, it actually makes some things easier. But either one of these basically for most of Calc 1 works, but we use this because we've got to get you ready for 2 and 3. So this is Leibniz, and this is Lagrange. Huh? No, you can see it because you've got the paper. It's the same thing that's on your paper. Okay, you got it. And then here, this is the second derivative, for example, right? So every time I take a derivative, couldn't I get a function? We just did. We took a derivative of x cubed. So watch this. If I had x cubed, what's the derivative of that?
3x.
3x squared. I love it. Isn't that a function in its own right? So I want to take a derivative now of that. So that would be f prime prime.
That's 6.
F double prime is how we say that.
6.
And what would f triple prime be?
6.
Good. I'll come back. So if I use the rule, it works. The 1 comes down, 1 times 6 is 6, and then the power goes to 0. What's x to the 0? 1. And then once we get to here, we go a little crazy with our primes, but once we get to here, we just start doing this, because otherwise we'd have like, you have to count all the primes, because we'd all go very insane. What's the derivative of this? Good. It's the slope, right? What's the slope of 6? It's got a 0 slope. Kick ass. So then what's every derivative after this?
0.
Okay. So I could have as many derivatives as I want. Not as you want, because you guys don't want that many. So this is like a reiteration of the proof I just did earlier. This is some simple derivative rule. Next time we'll talk about this because there's some nifty things that happen with sine. And next time we'll go over these problems here. But otherwise that's plenty for today. So I'll have the answer key for the practice test. Tomorrow we're going to get up through 3-4. And then the rest of the class will be devoted to review. Okay. Don't forget your ID. Who is this? Oh, Calvin, yeah. Hopefully Calvin's still here. Calvin? Oh. No, that's not Calvin. Oh, yes, thank you. Hey, all right.
This one's like almost out of battery.
All right, they all are. I gotta reach to them all.
Hey,
Yeah. Did I restart this? I did. Yeah.